In the previous chapter, we did material and energy balances to obtain a process model. Right? If you remember, the process model can be expressed in terms of deviation variables. So we get a deviation model. And what we did was we Laplace transformed the deviation model and rearranged the equation to obtain a transfer function. Alright, this process can be represented by a process block diagram, which we can see here. But this block diagram, however, is not that accurate right around here, because our control objective is the tank liquid height. And therefore, if we redraw the block diagram from a control perspective, right, we will have Q in, M in, and then we have H out, and we have this transfer function here. And if we so desire, we can simplify the transfer function and inverse Laplace transform it to obtain the final answer, which gives us the tank height in terms of time. Now let's consider this tank with the transfer function that we have derived, and now we have this tank installed with the level control system. Now, as you see, each of these level control elements has its own input and output, and therefore we are able to derive transfer functions for each and every one of them. So each and every one of them has their own unique transfer functions. And since this input and output of all these extra units are found in between Q in and H, we can actually draw a process boundary, all right, between Q in and H, encompassing our original tank as well as other components, right, to form a composite system. By doing this, we can combine the transfer function of all the components, including the tank, the level transmitter, the level controller, as well as the flow valve, and this will give us an overall transfer function that needs to be solved and simplified. All right, but and as you can see, this transfer function is not the kind of simple one that we have dealt early on. They can be handled very simply. It involves very complicated math if we have to solve this in the time domain. So instead, we take Laplace transform of all these transfer functions to take them from the time domain into the S domain, so that the math can be very simple. It only includes or involved with basic arithmetic math. And then we take inverse Laplace transform and convert the from the S domain back to the T domain with the help of our Laplace table, and we end up with some very complicated math in terms of T, and by doing so we solve the problem. So in this chapter we are going to look at a process, and we're going to analyze a control process. Alright, in this case it is a level control system. It could be a temperature control system, it could be a flow control system. Okay, and we're going to take this process and analyze it, and we will formulate a block diagram of this particular process. Right, and then with this block diagram we will then simplify the transfer function and solve for it.